As the demand for renewable energy rises and available farmland becomes more precious, an innovative solution is gaining ground. Agrivoltaics, which is also known as agrophotovoltaics, agrisolar, or dual-use solar. This practice involves utilizing the same land for both solar power generation and agricultural purposes. By integrating photovoltaic or PV solar panels with crops, livestock, or even greenhouses. This system creates a synergy that boosts land productivity while supporting clean energy goals. Originally proposed in 1981, agrivoltaic systems have evolved dramatically over the years. Modern designs include elevated solar panel structures that allow access for farm equipment and crop growth underneath, and panels installed on greenhouse roofs to maximize space. As the technology advances and interest grows worldwide, agrivoltaics is increasingly seen as a promising path towards sustainable farming and energy production. Just a reminder to hit the like button if you enjoyed this video. Thanks, let's continue. This system offers several significant advantages. One of the most important is the way they help plants. Solar panels provide partial shade, which can reduce heat stress on crops and help retain soil moisture, especially in hot and dry climates. This can lead to improved plant health and higher yields in some cases. Perhaps most compelling is the ability to generate two outputs, food and electricity, from the same parcel of land. This dual-use approach increases the overall productivity of the land and provides farmers with a diversified income stream. They can either use the electricity themselves, reducing energy costs, or lease their land to solar developers for additional revenue. In times of economic or environmental stress, this financial flexibility can be a lifeline for agricultural operations. There are several companies that have taken the lead in developing and implementing agrivoltaic solutions around the world. They each bring a unique approach to the technology. In the United States, Blue Wave supports farmers by offering systems tailored to specific agricultural needs. Similarly, SunAgri, a European company, helps farmers adopt a precision design to optimize both crop and energy yields. BayWa r.e., active primarily in Europe, provides end-to-end services including planning, financing, and system installation. Their product offerings include different setups such as interspace PV for traditional cropland and overhead PV for orchards and vineyards. The US-based RC Solar Company manages all aspects of its installations, which helps ensure consistency and quality throughout every phase of the project. In Switzerland, Insolite stands out for its dynamic systems. Their Insolagran technology uses translucent solar modules with adjustable light transmission. These modules can replace plastic tunnels traditionally used in agriculture, allowing for both light control and energy generation, an especially valuable feature for high-value specialty crops. These companies offer flexible business models including leasing, co-investment, and turnkey systems. Depending on the crop, livestock type, and regional climate, systems can be customized to fit specific farming practices. Farmers or landowners interested in exploring agrivoltaics can start by contacting companies that specialize in this dual-use model. Most providers offer full-service support, beginning with feasibility studies and site evaluations to determine suitability. System design is typically tailored to the specific crops or livestock involved. Financing is also available in various forms, including traditional loans, leases, and co-ownership models where farmers share in the system's profits from electricity sales. Some companies like BayWa r.e. look for particular land characteristics, such as flat, arable fields, where it may offer co-investment options that allow landowners to participate more actively in the project's success. The cost of an agrivoltaic system can vary greatly based on several factors. Location plays a key role. Areas with higher solar radiation and lower land costs generally see better returns. The size of the system also affects the price. While larger systems have higher upfront costs, they tend to benefit from economies of scale. The choice of solar panel technology is another variable. More advanced, efficient panels may cost more but produce significantly more electricity over time. Additionally, the type of agricultural activity, whether it's row crops, livestock, or greenhouses, will influence design complexity and installation expenses. On average, estimates place the cost at about $1.20 per watt peak, not including agricultural customization. For a 250 kilowatt system, total costs can reach around $3.50 per watt DC, or roughly $875,000. Ongoing operation and maintenance costs average about $20 per kilowatt DC annually, with additional fees possible for land leasing or specialized crop management. While the initial investment is considerable, incentives like the U.S. Solar Investment Tax Credit, or ITC, along with rising energy prices, can shorten the payback period to as little as 5 years in some cases. This system works best with crops that can tolerate or even benefit from partial shade. Leafy greens such as lettuce, spinach, kale, arugula, and bok choy tend to thrive in the cooler conditions created by solar panel shade. Root vegetables like carrots, beets, potatoes, radishes, and onions grow well without direct, intense sunlight. Legumes and low-growing plants, including peas and beans, benefit from temperature moderation. Berries and small fruits, such as strawberries, raspberries, and grapes, show promise under solar arrays thanks to improved water retention and reduced heat stress. Vegetables such as tomatoes, peppers, broccoli, and celery can adapt to the agrivoltaic environment with proper spacing and sunlight management. Herbs and high-value crops, including basil, cilantro, saffron, and mint, often perform well in partially shaded environments. Grains and forage crops, like wheat, oats, and clover, can be successfully grown, especially in systems designed to allow large area access. Flowers and beekeeping operations benefit from solar-friendly habitats designed for pollinators. However, tall crops such as corn or large fruit trees have posed challenges. Their height can obstruct sunlight from reaching the solar panels and limit energy production. Additionally, their presence may require modifications to equipment access or panel elevation that could increase costs. Despite its many benefits, agrivoltaics has limitations. Low to medium crop height is often necessary, especially in systems with fixed or low-mounted panels. Inaccessible layouts can also interfere with the use of farm machinery, complicating planting, harvesting, and maintenance. Some panel configurations, such as vertical setups, can reduce the amount of usable farmland and lower energy efficiency. Canopy-style or elevated panels address these issues, but require higher installation costs. Governments and agricultural programs, such as France's Agri-PV initiative, may enforce rules to ensure that agricultural productivity is not sacrificed for solar profits. For example, farmers may be required to maintain 90% of reference crop yields over 5 years. Other challenges include vulnerability to weather, evolving or unclear regulations, and the financial risk tied to upfront capital investment. Each system must be carefully planned to suit the specific crops, local climate, and soil conditions of the farm. Agrivoltaics is an exciting development at the intersection of agriculture and renewable energy. By enabling land to serve two productive purposes, growing crops and generating electricity, it offers a smart solution to land use challenges and climate goals. Farmers can benefit from reduced energy costs, more stable income, and improved crop conditions in some cases. Still, agrivoltaic systems are not without obstacles. Installation costs, crop restrictions, and logistical challenges require careful consideration and planning. However, with growing interest from companies, improved technology, and supportive policies, agrivoltaics is poised to become a vital component of sustainable farming and clean energy in the years ahead. Before you go, check out some of my other videos. Don't forget to hit that like button and subscribe. Thanks for watching. We'll see you at the next one.